For optical multiplexing, there are two main technologies used. Number one, there's the thin film filters, and then there's the arrayed waveguide gratings. The question is, when is what technology used and why? If you want to find out, stick around and we'll check it out. To understand when what is used, let's first have a closer look at the different technologies. Let me explain over here. So let's start off with the thin film filters. Now the thin film filters, they exploit the unique optical properties of film materials to either combine or separate different wavelengths. So how does that work? Well, to start off, we've got this substrate, and that substrate can, for example, be a little glass cube of 1 cubic millimeter. And that substrate is then coated with multiple different layers of a dielectric film filter. And what then happens is that that combination is then reflective for all wavelengths except for exactly one. And then depending on the combination of the dielectric film filters, you then can make it transparent for the different wavelengths. Now a multiplexer based on thin film filters is always a cascade. So in other words, we've got those different filters and that they are then cascaded to each other. Okay, now let's talk about the AWG, so the arrayed wave gratings. And as the name implies, they are based on an array of waveguides. But what does that mean? Let's have a look over here. We've got this incoming light, and that incoming light then passes through this first free propagation region and is separated onto the different waveguides. Now at this point, the separation is colorless. And that means that the signals going onto the different waveguides are identical. Now the different waveguides, they actually generate phase shifts between the multiple optical beams. And then combined with the different path lengths of those waveguides, the different wavelengths are first dispersed and then focused on these outgoing points of the second free propagation region. And the result is that we then have the different wavelengths. Okay, so when do we use what technology? Well, basically it comes down to the required number of channels. For the lower channel count, we generally tend to use the thin film filters. And that is because the thin film filters are very cost effective, and also it is a very flexible technology because we just can mix and match different types of filters to build a multiplexer. The point is that the higher the channel count, the less attractive thin film filters actually get. Well, for one, with each additional channel, we're adding a filter, so that adds to the cost. Also, the filter cascade also gets longer, meaning that the insertion loss will also then increase with a higher channel count. And last but not least, we've got the space topic, because the more filters we use, of course, more space we're going to require as well. So then we've got the AWGs, then obviously for the higher channel count. But isn't it also possible to use AWGs for the smaller channel count? Well, absolutely. Technically speaking, it is absolutely possible to use AWGs for a small channel count. However, the component itself is always the same. So in other words, you can't change the number of channels of that component. So in other words, if you're using it for 4 channels, it is the exact same components as if you were using it for 40 channels. And the result being that the cost per channel is extremely high if you're using it for a low channel count. So in other words, small channel count, thin film filters, high channel count, AWG. Well, okay, what is high and what is low channel count? Well, the rule of thumb is that up to 16 channels, thin film filters are better suited, and anything above that is the playing field of the AWGs. Okay, so I hope you learned something today and that you enjoyed this video. If so, please leave a comment and remember to share the video. Also, obviously remember to follow our channel so that you get your regular dose of brain snacks. Until next time, bye-bye.